All right then, I make it 10:15. Let's get this underway. Right, good morning everyone. Good morning. My name's Andy Wigley. I hope maybe some of you have seen the Jumpstart videos on Channel 9 or on Microsoft Virtual Academy. We just totted up the total viewings for all the videos the other day, and it's now over 500,000 viewings of those videos. It's just phenomenal. Well, thank you, I wasn't seeking that, I was just sharing that, it's just awesome. Thank you for that applause, yeah, thank you. Right, so this session, I'm going to talk about supporting LOB apps with SQLite, the SQLite database as a client-side database. So what I'm going to use is, the topics are going to be, first of all, just check you really need a database, because there are simpler ways for storing your data that may be appropriate for your apps. But having established that you do want a database on the client side, then why in particular SQLite database? Because we've got other ones that are available for Windows Phone and that are already in the SDK. So why another database? And indeed, why two different APIs? We've got SQLite-net and SQLite WinRT. This is the new one. So SQLite WinRT is one that Peter Torr showed very briefly in a session at Build last year when he was talking about using C++ code from your Windows Phone apps. And he showed this managed code accessing a SQLite database. SQLite is a managed DLL. But while we've got this new one, I will go into the details of that. But there's actually two different programming styles you can use if you're using SQLite.net or SQLite WinRT. So I'll explain what the differences are, and then you can take your choice. But this session is going to be mainly about SQLite WinRT. So then I'm going to take you through the basic operations, creating database, creating tables, and then doing the standard CRUD operations, create, read, update, and delete operations against a SQLite database. And then we'll look at transactions and relationships and other constraints in the database and how you work with them. A little bit about the tools that make it easier to work with. And then couple of little slides on if you want to ship a SQLite database as content in your app. So you've got a pre-prepared one and you ship it down to the client rather than create one on the fly. And then I'm going to just talk a little bit about data synchronization to wrap up. So this theme for the show for Windows Phone is just to drive home that Windows Phone is really ready for business. We've got great consistent experience across devices, and actually this SQLite WinRT solution works both on Windows 8 and on Windows Phone 8, so it's great for cross-platform solutions. And we've got, really, it's a great productive and connected system with all the Office 365 and other apps we've got in there. It's a robust platform, and this again is where the SQLite database comes in as a good component as part of your enterprise apps. And we've got great management, unified app and device management. So, to get into the topic of this database, first of all, I just want to check you really need one. If you've got relatively simple data in your application, then the simple solution is always the best one. And that means to just serialize it in XML or JSON, just serialize it to a file and store that in your persistent storage, in the flash storage on the phone. So then next time you start the app, you just deserialize that data, and away you go. And if you've only got simple data sets, that's all you need. So you don't need the complexity of a database. However, if you've got an example like this, which is a shopping list, and some sharp-eyed ones amongst you might recognize this slide, because I've stolen it from the link to SQL Deck that we gave when Windows Phone 7.1 OS, Mango, was released. But obviously the message is still true. If you've got a lot of data tables and they're related to each other, so here we've got different relationships. You've got lists of shopping lists, and obviously a list contains list items, and list items are chained in turn to particular stores where the items can be fetched from, and then there's history and favorites and all these kind of things, these complex relationships between the different data sets. You just can't really do that with flat files. So that's what a relational database, clues in the name, relational database. It handles relations between different items. That's what it's good for. So this example, if you've got a number of tables, lots of records, and foreign keys where you're getting linked back from one table to another, that's what it's for. The other one it's really used for is if you've got a very big data set, a huge collection of items. Now, you could try storing a dictionary into a flat file, but you're not going to end up with a good user experience, because what do? Do you have one flat file per each letter of the alphabet? And how do you handle that? And how do you store it in data? And then, because you couldn't load all that into memory at any one time in order to make it a reasonable app. So you're going to have some kind, you just can't do that with flat files. But with a database is built for this kind of thing, where you can have a large amount of data and you've got keys, indexes, so you can actually quickly go in and find the records you want and pull them out. That's another great example where a database really works for you. So, having established we want a database, why in particular the SQLite one? Well, it's the world's most popular database. That's a good starting point. It's widely used on a lot of other platforms. It's used in used heavily in mono and that sort of thing. It's public domain. SQLite.org is the organization that maintains it. It's small footprint, very fast and reliable. So you use it. It's not like it's no sort of database server or anything on the phone. It's actually an in-process database server. So it's just within your app, and you have all the features of a relational database available to your code. But the actual data is stored inside an ordinary file. So you've got a file in there, stored in your local folder, and that's where all the data is stored inside that database file. And it's got all the great features that we just talked about that you need, like multiple tables, indexes, triggers, and views. Cross-platform, that's interesting. You can actually have a SQLite database that's created on a completely different architecture, even like little endian, big endian, mismatch. You can copy it from somewhere else, copy it onto a Windows phone, and use it and open it directly. It's completely compatible. So the database format is fixed. Very reliable. It's got a good reputation as being very reliable, because they've got a SQLite.org. They have a very large, and if you go on SQLite.org, you get all the source of this. It's completely open source, so you get the source for the database engine, should you wish to use it that way. We don't, but you can. But there's a huge automated test suite on there, and they run this against every version, and there are versions of SQLite available for all the platforms. And all transactions are ACID. So ACID is the thing the database industry came up with to make sure that transactions are not, if they're interrupted, you're not going to end up with a corrupt database. So this is a good database engine to use. And this is it, SQLite.org. This is the organization who are responsible for this. And on there you can find all the documentation, which actually, when you're using SQLite WinRT, you will want to refer to this, because on there is the SQL syntax. And we are working with SQL statements with SQLite WinRT. There's also the C and C++ API reference, which is kind of interesting. You won't need to look at that too much as a developer, but it will serve as a good reference point. When you see the methods we've got in this component, they are thin wrappers around the C, C++ API. So if you're coming as a developer from another platform, and you're used to working with SQLite using SQL statements and the C and C++ API, you're going to feel very comfortable with this. This is one of the goals for this new wrapper. And all of the source, and there's a few tools available on there as well. But we already have a database on Windows Phone. We have had it since 7.1, since Mango. And that's known in the docs as the local database, but it actually is SQL Server Compact Edition, version 3.7-ish. So that's available, and that's still 100% totally supported. We're not backing away from support of that database. But it's not available on SQL CE is not available. This link to SQL API is not available for Windows 8. So if you're doing cross-platform development, you want to share code between your phone solution and your tablet PC solution, then link to SQL, the SQL CE is not a solution for you. Actually, I've got SQLite. I've got a cross there saying SQLite's not available on Windows Phone 7.1. The proper SQLite database engine is not available on Windows Phone 7.1. There is there's a SQLite community thing that actually is a C# library that exposes an API that kind of works with, it works with SQLite databases, but it's actually not the SQLite database. It's a simulation, if you like. So to my purposes, that's not available on Windows Phone 7.1. So yeah, if you go in Windows 8 Store as well and you want to share code, then SQLite's a good choice. If you want to use link to access your database objects, and I'll show you in the next slide what that actually means if you're not clear what I'm talking about, that's the only API that's available for the local database, the SQL C solution. It's link to SQL. You're using link statements to pull objects out of your database, and it sort of materializes them into in-memory objects. It's got a built-in object relational mapping technology that's built in a part of that. SQLite, well, actually, you can still use that object layer if you want, using the SQLite.net solution, which I'm not going to talk about this morning. So that's still available too if you prefer to program in that way. And like I said, I'll show you in a minute, do a comparison between the two SQLite wrappers we've got. If you want to execute just SQL statements, if you feel more comfortable using SQL statements, you can't do that with Link to SQL. You can absolutely do that with SQLite. Yeah, cross-platform. Both support views and foreign keys. That's good. Neither of them support stored procedures in the way that a back-end server database person would understand. This is a small in-process thing, so that's one thing that we haven't got. But with SQLite, we do have triggers, and triggers are very useful, and it's the key to making the replication bit I'm going to talk about at the end work. So that's a big plus over Link to SQL. Now, on encryption, just a quick word about the security side of things. You can put a password into the connection string for a Link to SQL. SQL CE, and that acts as a key, and you encrypt the whole database file. You can't actually do that with SQLite as encrypting the database file, but I would argue that's probably not too much of a problem, because if you say you've got an enterprise deployment situation, you've got fully managed devices, then you can turn on BitLocker anyway. So the whole of the flash storage on the phone is encrypted with BitLocker, so that's pretty secure. And also, of course, we've got great encryption APIs available in the base class library. So if you've got a particular column that's sensitive data, you could encrypt it before you store it away in the database. So there's still encryption solutions available for you to keep your data secure. So if you want to use SQLite, the first thing you need to do, you need to install the SQLite extension SDK, which you go onto the Visual Studio, you go onto the Tools menu, and down there's extensions and updates. And this is where you can install extension SDKs. And you'll see a window like that. It goes off to the cloud, and you can list all of the different components that are available. There you can see a shot of where SQLite for Windows Phone and SQLite for Windows Runtime. So that's the database engine versions for both the phone and for Windows 8 store apps have been installed. That's a shot off my own dev PC. So you install that, and what that actually does, all that gives you really is the SQLite 3.dll, which is the database engine. It's a native DLL, and it sticks it down into C, program files, 86, Microsoft SDKs, Windows Phone. You can see the path there. Version 8, extension SDKs, SQLite.wp80. And also underneath there will be a version. And whenever a new version of this is released, and a new update tends to come through every couple of months or something, they fix something, then you'll get notified in Visual Studio that an update is available and you can refresh it. Just one word of warning when that happens, the solution that we've got on Codeplex, it has a dependency on a particular path. So when you upgrade the SQLite, this SQLite extension SDK, all at that point Visual Studio won't be able to open your SQLite WinRT project anymore because the path references are wrong. And there's no easy way of doing that other than editing the project file. But I'm going to put on Codeplex, one of the great advantages of coming to TechEd is all these clever people. So I went over to the scripting guys yesterday and I said, can you write me a script to automatically go and search what the path is over here and automatically edit this project file? And they said, sure, I'll do that for you. So they did it for me, and I'm going to post that up on Codeplex. I might even do that this afternoon when I get a minute. So I'm going to try and make it easy to do that. But just a word of warning. So if Visual Studio cannot open the SQLite WinRT project, it's probably because it's been updated and the references aren't quite right. So what have we got when you've installed that? So this is our dev platform. This is the Windows Phone 8 dev platform. And as you know, we can create XAML apps in C# and VB, and they can call the .NET APIs, which are the ones in blue, and they can call the Windows Runtime APIs, the ones in red. And we can also do C++ dev, but this is mainly obviously for the games development community. So they can call all the C++ stuff there, the C runtimes, standard template library, and all the Direct3D and the native audio APIs and all that kind of good stuff. And they can also call the Windows Runtime stuff in the middle. Now, when you install that extension SDK, what you're actually installing is a native DLL, SQLite 3.dll. And so it kind of sits over there in the green area, really. So we cannot call that directly from our C# and VB applications. The C++ devs can call it directly, of course, so they can call straight down into use the C and C++ API that's documented on SQLite.org, and they're happy they can use that directly. But for us, I'm speaking as managed code developers, then we need to have a wrapper around SQLite 3.dll. So what we do is we create a Windows runtime component. It just wraps around it. And then there's other bits in the chain as well. So actually, the wrapper is SQLite WinRT, is the wrapper. Is a Windows runtime component, the one I'm going to talk about this morning. SQLite.net actually has two bits to it. It actually has a Windows runtime component wrapper and a managed API as well. So they're slightly different there. So I said I was going to tell you what the differences are. So this is SQLite.net on the left. Like I said, this is link syntax, very similar to the SQL CE local database solution that we've got in the Windows Phone 8 SDK. And with that, you're doing link statements. So you do, from C in db.table customer, where clause, select C. So these are link statements, but they're actually calling straight down into the database and pulling the objects out of the database using link statements. And this is a great way of working. I love working with with objects. I'm not saying that this is better or SQLite WinRT is better. I'm completely agnostic about that. But what we are hearing from our community is that a lot of people like working with SQL statements. So actually, a show of hands, who prefers working with SQL statements when they're working with a database? Yeah, you see, there you go. So this is for you. SQL WinRT is for you. So that was around half for people listening to this recording. So, but then a lot of people love objects. So we've got two great choices here. So if you love objects, then that's the one for you on the left. If you prefer working with SQL statements, then SQLite WinRT is the one for you. And what it is a very thin wrapper around the SQLite C, C++ API. So SQLite C, C++ API has this prepare statement method on it, where you actually get your SQL statement and you get it ready for executing. So in our API, it's called prepare statement async. So this is a very modern, it's a Windows runtime style API that we've built here. It's all asyncified, and it throws exceptions when things go wrong. So it's very much in the modern idiom. And in the C++ API, the C, C++ API and SQLite, to execute a statement, perhaps weirdly, they call the step method. So the statement.step is how you actually execute a statement. So in our API, it's called step async. So it's very close. It's just a thin wrapper around it. So this is why I said sometimes you might want to refer to the C, C++ API documentation just to figure out maybe a bit of insight onto some of the APIs in this new wrapper. But, as like I said, I'm not talking anymore about SQLite.net, but there's some great resources for you there on the slides. Windows Phone Developer blog, there was a post there which was all about using SQLite.net. And then Tim Hewer, who actually I think SQLite.net is his baby, actually. He wrote a post on how to use it with Windows 8 apps, but a lot of the stuff in there still applies to Windows Phone as well. And Eric Jensen, he's got a great post there as well, getting started with SQLite, and you will find others. But those are references on SQLite.net. From now on, I'm going to focus purely on the new guy. So it's up on Coplex. It was published just last week, so this is brand new. So it's Peter Tor's wrapper. I've worked with him, and a few others have worked with him. So it's an enhanced version of what he showed last year, and he's put a bunch of work into it, and I've put a bunch of work into it. And the result is this up on Coplex. It's called, you need to go to sqlwinrt.coplex.com. Now, when you go there, there isn't actually an official download. So when you go on Coplex, sometimes you go to downloads and you expect some kind of MSI or something. There isn't that. What you need to do is just download the source code. So there's a link on there which allows you to download the source code. And what you get there is a complete Visual Studio solution with two projects in it. And one is the phone component, and the other is the Windows 8 component. So all you need to do then is just copy the phone component out of that solution and stick it into your solution and add a reference to it. That's it, you're good to go. So let's just show you how that looks in reality. So it's an empty, so first of all, tools, extensions and updates. And I've actually got installed, I've got a bunch of stuff installed, but you should see down there, I've actually got SQLite for Windows Phone is one of the ones I've installed. But if it wasn't, you would go online to the Visual Studio Gallery, and then you can go and search for SQLite, and it would go off and find it, and you can see there's all sorts of bunch of stuff. So then it's already green ticked on mine because it's already installed. But this is where you would then go, and there would be a download button, and you click that, and it will download it to your machine and install it. So that's the first bit. And then you have to Coplex, and I'm going to create a new project, actually, first of all. New project, and it's going to be a Windows Phone app Phone app 2, that's good enough. Okay. It's Windows Phone 8, and just an standard empty Windows Phone managed project. And then I've already been to Coplex, and I've got that solution. So then what we do is add to this solution an existing project. And this is the project. So there's a VCX proj, and add that into the solution. There we go. And then I'm just going to add reference from my managed project to that one I've just added. Okay. Now this is the WinRT component. It's not a lot of it, to be honest. We've got a database.cpp. This is C++ code, of course. And there's a utility method called platform string to char away. But there's OpenAsync, and this is calling OpenAsync, and we've got some flags on there. This is how you open a database connection, all sorts of stuff. And here we're calling the SQLite 3 OpenV2 method, which is one of the native API calls on the C++ API, and you can see all this stuff. I mean, I'm not going to go into this. This isn't important. This is the work we've done for you in order to allow you to use it. And you can see that's it. You get the source code, so you can dig into it and understand it and enhance it if you like. And the other main class is statement.cpp. So you can see this is not rocket science. We're preparing statements. There's some various error handling stuff. There's step async, and a few get parameters and things for filling your statements and things, which I'm going to go to now, so I'm not going to go into that. So that's the wrapper. That is our component. And we can build it, and it should work. All very good. And now I'm going to go off and just, you can start doing things like actually building your database. So let's go down here, and let's create a new method called a load database, which we're going to call from application launching. And we can generate some method stuff for that. And then we're going to put some code into this new method. I'm going to async, put the async keyword on there already, because there's loads of async in here. And then we can do something like var db equals a new SQLite WinRT phone dot database. So you can create a new database object. And we now can, there's a couple of overrides of that. You can give it a storage file, or you can give it a storage folder and a string name. So I'm going to create this in the application data, which I need to resolve using windows.storage, application data .current .local. So it's going in the local folder. And if you want a read-writable database, it needs to be in the local folder. And then we can give it a name, which we'll call it test.db. Extension doesn't matter. You can call it whatever you like. And that's all that's doing is setting the path, if you like, where the database is going to be. And then we call await db.openasync. And what that will do is, if the database doesn't exist, it will create it for you. And if it already does exist, it will just open it for you. So we've got to open our database file, and then you can do stuff like create ourselves a SQL statement equals. And then we can put our something like create table if not exists. That's not handy, because you can execute this multiple times, and it won't error if you do it. And then we can go over here and we can put a table name, which is customer, and then we can give it a column. And this is all standard SQL stuff, and we can have that an integer. Ooh. I see now the reason why it's done that is because what I need to do, if you can do multi-line statements, you put an ampersand on there. Thank you very much. And so you can turn off the IntelliSense. So it's an ID, and it's an integer column, and maybe it's also a primary key. And, and you get the idea, and obviously not null, which I think is implied anyway if it's a primary key. And we could put another column on there. So let's have another column of name on it, and we can give that a type of varchar. Maybe that's 140. And that's probably good enough, actually. So that's our SQL statement. Oh, no, go away. Yeah, and then I'm going to execute this. So are we... then we go await db.execute execute statement async. So you can execute a statement like this, and we put that SQL in there, and there we go. And we should have, if we just execute that, we should have a database. It wants us to rebuild. And, what's wrong with that then? Well, there you go. Thank you so much. All right. Yeah, so obviously got some SQL geniuses in the room. Good, I'm going to need it. Yeah, there we go. Isn't that the most fantastic, stunning demo you'll see? All TechEd? Well, it didn't crash. No, that's not terribly interesting as a demo. So actually, I'm just going to give you a sneak preview of the one that I'm going to look at next, which is that one. And this is a proper solution. So this has got all sorts of create table not exist, got a couple of tables, we've got foreign keys, and all sorts of stuff. So obviously this is a proper solution, but I'm just going to push that to one side and do a few more slides before we get on to digging deep into that one. All right. The basics. So this is the simple stuff to get started with this. Obviously, I've said this already, the SQLite WinRT really is a thin wrapper around the C API. So we're interacting with the database using SQL statements, which hopefully you can spell right, and parameterized queries and statements. So this is going to be very familiar to you from it's the database model we've used for quite a while. So this is how you create a database. You saw me start that sort of thing there. But I just want to call out one particular thing on there. You'll notice that, like I said before, this is a modern API. So if something goes wrong, it will throw an exception. So we're not looking at return values particularly, unless it's actually returning data, of course. So we execute the statement, and if actually I had put that proper exception handler on there as well, I would have been able to come back and get the SQL status code that would told me my SQL was wrong. So this is the pattern you'll need to use to figure out what's going wrong. We've put this get SQLite error code method on the database object, which allows you to take the H result. This is one of the downsides of this, the SQL runtime components thing, is that it talks to you in H results. We thought we'd done with them, but they're back. And so you get an exception that's not in it, not at first glance particularly readable. But at least with this extra method now, you can analyze the H result and find out what's actually gone wrong. So then, having created our connection, so I'll just go back to that previous one. So you're getting a DB out of that var. Well, it's a var DB actually. But if you imagine that that DB connection that we've opened is actually exposed as a property on our app class, then this is what we're doing here. We're getting that reference to that open connection with the top statements there, and then we're using prepare statement async. So this is where you can use a SQL statement with named parameters in it. There's two flavors of this. This is with named parameters. You'll see we're inserting into the customer table, which has got columns, name, city, contact, and we're putting values in there, and we're naming the parameters that we're plugging into that, at name, at city, and at contact. And as it say there, they have to have a leading at or a colon or a dollar. And then you can use these bind text parameter with name methods, or bind int parameter with name, or bind int 64 parameter with name. There's different flavors of it, depending on the type of the data type. And then that actually plugs the values into that statement, and then you call custStatement.stepAsync to actually execute it. So that's the model for using a statement. A select ID, name, city, contact from customer, where ID equals some value, and then just step async, and then you get values out of it. Now you'll notice that when you get the values back, you've got to kind of extract them from the statement. So we've got we're creating a new instance of a customer view model, which is a custom object I've created in my application, and we're going to populate the fields in that with the values we've got back from the database. So you call get int at 0 to pull the first column value out, and get text at 1 to get the second column value out, get text at 2 to get the third, and so on. And as you see, it's 0 based. So you pull the values out, and plug them into your own view in-memory object for then using further on in your application. The alternative select, we can enable this columns property, And Peter Tor himself said it isn't super useful, as all columns are returned as text and must be parsed. But instead of doing that numbered columns thing, you can actually reference the data you've got back from the database by using its column name. And here, we're doing the same thing, but we're getting the columns out of that statement, and you can then, it's like a dictionary, string value dictionary, in order to pull the values out that you've got back from SQL. But it says there, everything comes back as a string, which is kind of weird, which means you have to parse if you're in an integer and that sort of thing. But at least gets rid of these magic numbers, which are not particularly great with the previous way. An update. Well, this is actually kind of similar to the insert that we looked at, but this time, instead of using named parameters, I'm putting anonymous ones in. So these are question marks. So here, if you remember from the insert, it was bind text parameter using name. This is bind text parameter at, and there's bind int parameter at and bind int 64, different flavors of it. And you have to use the first argument to that is the index of the parameters. Now, unfortunately, it's 1-based, this one, not 0-based. It's, well, you know, I did think about when we were doing this, I thought maybe we should make this 0-based for our audience. But the objective is to be a thin wrapper around the C++ API, and that's what it does. So that's what we'll do. So, you know, but you can get the source code. If you want to change it for your own organization, you can change it, make it 0-based, and cause chaos and disaster. And delete, of course, delete from customer where ID equals whatever, and then execute statement async. So all simple stuff, really. Well, these are all the CRUD operations. Right. I've got a demo, which is going to be on my blog in the next few hours. I was writing it this morning, and I hoped to finish it before this session started, but I didn't manage to do that. I was saying to Ginny, it's amazing how you can stand up here and explain something, and it takes you a couple of minutes, and you're thinking, how long could that take to write it down? It takes a load of time. So it's going to be, this sample is going to be up on my blog, which is andywigley.com. So you want to go there, andywigley.com. This sample will be up there, and you can pull this down and play with it yourself. So I'm going to run this up, and I've got loads of breakpoints in it, so we can just walk through some of the interesting things. First of all, we're in app.xaml.cs, so this is similar to the code I was just showing you here before. And we've got a load database method, and we can step through this and see what it's doing. So this is called from application launching. It's also called from application activating as well. So we just make sure we've got a proper database, regardless of how it gets started. So there we are. We new up our database object, call open async, call create table if it doesn't exist. I've got this statement here, this method here is just so I can put a bit of logging in. But we execute the SQL statement, write something to the debug window down the bottom right in the center there so we can see what's going on. And we can do our exception handling as well. So that's the first one. And then we create a project table. And this has got a number of fields in it, including it's got a foreign key reference back to the customer table. I'm going to talk about that in a little bit more detail a bit later on. So we'll just put that to one side for now. And we're creating the project table, executing that one. Oh, this is interesting. Right. Now, we haven't quite finished with that. This is very timely, actually. So I'm going to step into this method. This is what we've ended up here is mainpage.xaml.cs, and we hadn't quite finished the load database stuff. This is one of the kind of Achilles heel of async programming, is that stuff's firing off in all directions, and you don't know when anything's finished, and you can get weird things happening, and you thought something had done, and then your code comes in, and it hasn't done. So if I step into this, what we're in here, this load data is in the, is called from, here, on navigated to in main page, the first page of the app. So we're going off to the database. We're trying to get all of the customers out of the database. Actually, we haven't finished building the database yet. So, but because of async and everything, this is actually happening sort of out of sequence. So actually what we do here is, this is the method. I'm going to talk about this in more detail in a moment. But this first thing here, await app.getDatabase async. This is actually all your data access code in this sample. And this is we're trying to do a really good, real example with this. This isn't a kind of brain-dead, absolutely simple sample that you see at TechEd. You know, this is actually proper way of doing it you can use in your own solutions. This method is kind of like a gatekeeper. And inside it, app.getDatabase async, what it does, it's over here. you'll notice actually, first of all, you see this dbloaded.set, which is the last thing my load database method does. We hadn't quite got there yet. What that is a manual reset event. It's an old-fashioned semaphore called dbloaded, and you new it up unset. And then this is that get database async method that we were just calling from over in our view models. And all of your data access logic should call this first. And this is all this is doing is it uses a task, so it spins it off onto a background, and it calls a dbloaded.wait1, and that will block until that happens. So it means that your view model code in your pages can't try and open the database and get data out of there before your actual initialization logic has completed. So that's what a manual reset event does. And all your logic should just call this method, which is where we were. I'm going to hit F10. I have no idea where we are now. OK, we got through that. So actually, the other stuff in app.xaml.cs must have finished. And then in this class here, we're trying to get all of the customers. This is a table view model base. This is our base class. So up in my view models folder, I've got this table view model base. And I've got a bunch of customers view model, these things, which this inherits from table view model base. So you create one of these for each one of your actual your tables in the database, and it inherits from that base table view model base. Which is this here, and this has generic method. So this is a get all items generic method that will, regardless of the table you're getting, will get all of those items out of it. And what it does is step into it. It actually prepares the statement, and it calls the child class to get the right select logic for that particular table. So it calls out into, in this case, get select all SQL in customer view model, customers view model.cs, which returns to the base class select ID, name, city, contact from customer. And then it then calls fill select all statement. And that is another method that's overridden. So just to drive that home, you see these are all abstract methods. So these abstract methods in the base class have to be overridden by the child, which is so this is the generic base class. And then it calls out to fill select all statement in the child class, customers view model, which in this particular case is nothing to do. And then we execute it, and so and then we'll return to the item but that while statement didn't execute because we haven't got any data in this database yet. Right. So here we are, customers. Let's make this a bit bigger actually. There we go. I've got no data, but I have got down here. I've got a menu option called Reset Data. And this is just seeding our database with some data. So we got delete from project, the gatekeeper method, again, get database async. We execute delete from project, so we're emptying the project table. We're emptying the customer table. There's nothing in it, actually, at this case. And then we got a bunch of tasks which do insert customer, and we continue with insert project, then the next insert customer, just show you what that does. Which again is this prepare statement async stuff and setting the values in, executing it. So you can see how that all works. And then we also get in this insert customer, we're also then having inserted, because this table auto sets the ID. It's one of these whatchamacallit. It's that, what is it? I can't remember the name. It does auto increment, sorry. So the database assigns a new ID to it, so we want to find out what that is. So we then do another statement against the database to find out what the newly allocated ID is, and we return that to the caller. So then we can plug that ID.result into the child projects. So this is all just seeding all the database, and let's just let that run, and now we've got some data. And I can select anything in this list. Let's select Contoso, and now we're into a new page, customer projects view.xaml, and this is being called from our onNavigated2, and it's going to call get item async into my view model class, so we dive into that. First of all, we get an instance of customers view model, get the default, and then we call the get item async, and we're back into that base class, a different method in that generic base class. Gatekeeper method again, we find the statement. This is the statement. Select ID, name, city, contact from customer where ID equals some value. and then we fill that statement, step into the child class, which supplies the key value. So the key value is being passed from the list, and now we're now going to go and find the right record. Let that run. And this is Contoso, that particular customer. And we've also got some projects on it. We've actually got one project on here. And of course, we can add new projects. So we can put this party. This is called Part A because we're going to the attendee party tonight. And of course, that's tonight. And so we can save that. And here we go. This is the logic. I'm not going to bore you by doing too much. We insert item async. We're going to this sort of stuff. It's all the same pattern. So you can get this sample and study exactly how it works. Insert item async. There's the gatekeeper. There's our statement. And so all this, it's all the stuff that you'd expect is in this sample. And there we've got our party, and that's all very good. I'm going to disable the breakpoints because it's getting boring, and just let it run. And of course we can delete stuff, and it's all good, and it's all in a database, so I can start it up again, and there we are. So this is a fully functional database-driven application. All right. Well, it wasn't that good. Come on. I have sweated weeks building this thing. Right. Like I said, that code will be on my blog, andywigley.com, within a few hours. It's mostly written. I just need to finish it off. Okay, so that was that. Right. What about transaction relationships and other constraints? So every change you make to a SQLite database happens within a transaction. If you don't actually declare a transaction, it implicitly creates one around your update. So any command that changes the database will execute within a transaction if one is not already in effect. But if you want to execute a number of statements all together, and you want them all to succeed, or if there's an error somewhere, none of them to succeed, you can start a manual transaction. You simply execute begin transaction at the top. You can actually just shorten that to begin. And then at the end, when all the changes are ready to be applied, you can then just execute the commit transactions statement. Or if something's gone wrong, you can roll back, and none of the changes will be applied if you do a rollback transaction. So it looks a bit like this. Execute statement async, begin transaction, and then you do all your updates, do multiple inserts. There's only one shown on the slide because I didn't have room for more. But you do a bunch of updates, inserts and updates and deletes and all sorts of stuff. And then at some point you decide your logic that you want to roll this back, and you would execute statement rollback transaction. Or if everything's good, you say commit transaction, and then all the changes will then be applied. And also, if you're doing multiple inserts, it's worth doing this anyway, because otherwise it can be quite slow doing loads and loads of inserts. But if you wrap them up in a transaction, it's super fast. So that's probably the way to go. Now, of course, the other thing a relational database does very well is controls relationships between records. So we've also got, in this sample database, we've got two tables, a customer table, and we've got a projects table. But there's a relationship. One customer record has a collection of 0 or more child projects. And each project, in this particular example, can only belong to a single customer. So there's that relationship, parent-child relationship. Other relationships are possible, of course, many-to-many or this sort of thing. But this is a one-to-many relationship. And the way you represent that in the database is that the child object, the project in this case, will have a column in it which is used to store the ID of its parent customer. So then it's very simple to find all of the projects that belong to a customer. You just do a select from project where customer ID equals some value, and they will just pull them out of the projects table. And foreign key constraints enforce the relationship and maintain DB integrity. Well, yes, there's a slightly odd thing about here. So this is how you define a foreign key constraint. You saw that on my create table statements. So the actual data is stored in that customer ID, the bolded customer ID integer column. But then there's a constraint applied and the database, which is there to make sure that you can't have, you can't put rubbish data into there. So every time you insert a project, the idea of this foreign key constraint is that the database engine will check that the data you're trying to insert, that the customer ID value is valid and does actually map to a parent customer record. That's what a foreign key constraint is for. However, they're actually not enabled by default in SQLite, which is kind of weird. This is just for backwards compatibility. SQLite has been around for a while, and foreign key constraints were added after the day. So they made the decision at SQLite.org that actually this feature, you can define foreign key constraints till the cows come home, but it will ignore them unless you actually execute this pragma. So you need to, in your startup logic, you need to execute this pragma foreign keys equals on statement for it to actually observe your foreign key constraints. And if you forget, they'll just be ignored. And there are a bunch of other constraints. Obviously, the primary key constraint, you need one per table for that. There's unique, which you can put on a column, and it enforces that every object that's stored in that table will have a unique value in that particular column. Not null, stops you from putting null values in. And there's also check constraints, which is a little bit of SQL that you can execute whenever an operation is on every insert or update. And if it returns false, then that check constraint fails, and you'll get an exception. So you can put some kind of logic in there. So what this is all about is constraints are there to, I mean, you could do all this obviously in your application code, but it's a much better idea. What you're doing is you're putting stuff in the database, using the facilities in it to have your database in good health. So you can put these constraints on and stop it from creating this bad data in your database. Now, the other thing that's slightly odd about SQLite, if you're used to other databases, is that actually you can insert any data type into any column. So you can have a database table that's got int columns and date time columns and blob columns, but it will not stop you from putting a string into an integer column, a floating point into a Boolean column. You can do basically what you want. Now, this is kind of slightly odd. It's called dynamic typing, but it's what it is. So when you actually when you create your table and you say, okay, this column is a integer, if you then try and insert a string into that column, what it will do, it will use that integer as a hint, and it will try and do the right thing. So if it can parse it into an integer, it will do it and stick an integer into there. But if it can't, you've given it complete nonsense, you've given it a string that cannot be parsed into an integer, then it will just stick the string in. So, this is really just to make you aware. This is a feature, it's called type affinity. It seems slightly scary to me, but if you ever end up with a database with weird data in a column, that's why. So I can't think of imagining a situation where you'd want to take advantage of that feature, to be honest, but there you go. Indexes are very important, particularly with foreign keys. I said that thing about, it's dead easy. You've got a project table, and if you want to find which projects belong to a customer, all you need to do is do a select from project where customer ID equals 93 or whatever, and it will go through and find all the records that match that, have that customer ID value. But if you haven't put an index on it, the only way it's ever going to find out is to start with record 0 and go all the way through and to get right down to the bottom. It's called a table scan, and it's a standard performance killer with databases. So you must make sure you put an index on any column where you're doing random access. And you can create a number of these. So you can use the create index clause to do that. And this is an example of doing that for the customer ID column in project. So that's actually allowing for efficient lookups. And put indexes on anything like that where you've got a large number of records and you need to do efficient lookups on a sort of random access way. So I'm just going to fix this. I'm going to show you how the constraint thing works. So back to our app here. And I'm just going to close the app and stop it in here. And then before we run it again, I'm going to, let me enable my breakpoints again. And I'm going to go down to app.xaml.cs. And like I said, there's my foreign key constraint that we put into the database. But then I'm just going to comment out the pragma bit. So I can now go and run this again. And and we can go off into, yeah, I don't want that one anymore. Let's go, and we're not interested in that anymore. So let's go, and now we've got our thing. So now we can go off and go off to Contoso again. Okay, and here we go in projects, and now I'm going to add a project. What shall we have a project for this? Another party, because actually we deleted the other one. And then attendee party tonight. Should be a blast. Now, actually, having enabled my breakpoints, the reason why I hesitated there is I realized, because I did this before, didn't I? And it didn't actually hit a breakpoint. So, just let me fix, where do I want to go? Into project view model, and then I want to put a breakpoint on here, which is where we fill the insert statement, because I'm going to fix it with bad data, because actually my application is so carefully crafted that it's impossible to put bad data into this thing. But now, here we go. So I'm going to let that run. We're into the insert a project, and we're into insert item async. Oh, there was a breakpoint there. Here we go. So we're in the fill insert statement. So we've got our statement, which is just as shown above there. Insert into project, customer ID, name, description, due date. And the values are all in this item thing. So I'm just going to do a quick watch on that. So here's my item. So the values is got a proper value of 2 in there, but I'm just going to edit that value and put a nonsense value into it. Make sure it takes. There we go. It's now customer ID 99. We don't have a customer ID of 99. So then I'm going to let that run, and it will. Now it's set that bad data into it, and now it's executing it, and that works great, even though it's an invalid customer ID. That's because the pragma has been disabled. So we can let that run and order that. So let that run, and it's not there because we've managed to create a disembodied child record. It's in the database, but we can't actually get at it. So that's bad data we've introduced to our database. So now go to app.xaml.cs and put that pragma back in, if I can find it. There we go. And just repeat that exercise. Projects, add another one, and I'm not going to bother thinking of anything intelligent. Save, and back into all this stuff. Here we are, back in the same place. I'm going to do what I did before. Quick watch, and go down here, change it to, I don't know, 56, 7, there we go. 567, there we go. And just let it run, but this time we've caught an exception, which is a constraint violation exception. So that pragma, you can see how the database here has detected that you're trying to insert bad data. So it shows the value of making sure that you take advantage of these constraints to make sure you've got good data in your database. All right. A little bit about tools. If you go on SQLite.org, there is a command line tool there. You can see that at the bottom of the screen there. It's called SQLite 3, and you can create databases and tables and execute SQL statements and do everything from a command line tool, which is for those of you who like to work that way. But most of us like to work with IDEs, and there's a bunch of them. If you go onto SQLite.org to that URI on their wiki, there's a whole list of management tools, and I'm not going to recommend any particular one over another. If you do a search on the internet about recommendations, you'll tend to get back about 12 different suggestions from various people. I think there's a lot of good ones out there. SQLite Studio I've been using, which is very good, and these other ones. So there's no particular recommendation. Just go and find the one that works for you. And you can do all the stuff you might expect to do, such as you can look in your tables, and you can design your database, and you can add columns and indexes, and you can execute statements. It's actually very useful having something like this available to you, because especially you saw my very first demo, and I got my select statement wrong. it's easier, actually, to kind of, if you're getting a problem like that, is to pull your database off onto the desktop and execute this tool against it, and then copy your SQL statement into there, because this will give you more feedback about what's wrong with it. So it's very useful. The key thing there was I mentioned is that you've got to copy the database from the phone onto the desktop. None of these IDEs are going to go off onto your phone or the emulator and be able to work on a database that's there. So you're going to have to copy it back first out of your app in order to sort of have a poke around and have a look. And you could use the Isolated Storage Explorer tool for that. That's in the Windows Phone 8 SDK. And that's, again, another command line tool. And that's great and works super. Or, again, there's a bunch of nice GUIs that take the pain out of that. And the one I like to use is the Windows Phone Power Tools, which is on Coplex, wptools.coplex.com, which looks a bit like that. And that's really useful for, it's a desktop tool you can run, and it can go and look at what's on the phone and pull stuff back. And in fact, I've got a demo I can show you just that. So close that app again. Right, so first, I'm going to run up the Windows Phone Power Tools, which is here. Oh, it's already running. Let me just show you what it looks like when you start it up. There you go. So you get to connect to a device. You can choose what you want to connect to, whether it's a true device or an emulator. I'm going to connect to the emulator I've just been using. Connect to this. It's connecting to the device, to the emulator. And now you can install and update your developer app, your Zaps, into using this tool. And you give a list of the apps that are on it. You can give them a proper name, actually. So normally, when you see this, you just see the GUID. That GUID will be the one I created first. This one I have, this sample, you won't be surprised to hear I've practiced a few times. So I gave it a name. This is like a SQLite WinRT test app. But when you first connect, you need to figure out what the GUID is. And the GUID is, you find that out just by opening up the app manifest and go off to packaging. And that's your product GUID, that one there. So you go off to find your particular app. It tells you all about them. You can uninstall and launch them. But this is the interesting one. This is where you can actually go and get the files. So here's SQLite WinRT test. Expand that out. There's my demo database. I'm going to get that from the phone. I'm going to stick it somewhere. I'll stick it on the desktop. Onto my desktop. That's done it. It's copied it off the device onto my desktop. And now I can run up my tool to go and have a look at what's in that particular database. And you get some nice tips. I'm going to add a database. Go off and find the one I've just copied. There it is, SQLite demo.db. OK. And then I have to connect to it. And there we go. And now we can start having a look around. It's going to be quite small for you. I don't know if you can get it a bit bigger. No. All right. So we can look in the customer table. And there's my customer table. It gives you the columns. You can look at the data that's on it. There's the data that's in the table at the minute. This is quite useful. You can look at the DDL. So actually, those create table statements. All you need to do, you can do your database design up on the desktop in a tool like this where it's easier. And then once you've got your database design right, come on here and get the DDL, copy this string and stick it into the statement that you're going to execute in your code. So that's all very useful. So that was that. And the project one, we can do the same thing. There's all the data. Sorry, the structure. There's the data. There, see that bottom one? There's that disembodied record that I managed to create while the pragma was disabled, the 99 one. So you can look at the data and have a look at the indexes and the triggers and the DDL. So there you go. Oh, yeah, and you can execute statements as well. So you can do things like select max, I don't know, ID from customer. Let's find out what the maximum ID is. And we can execute that, and it will tell us the max ID is 4. So you can execute statements and try stuff out. So it's really, really helpful and useful for working with the databases and having a look around. Just a little mention about working with pre-built databases. This is where you have got a database from somewhere which is already full of a lot of data. And you are including it in your ZAP file because maybe it's static data that is referenced and doesn't get updated or something, but you want to ship it as part of your app. So you can just create your database, stick it into your project, add it as content, and then it will just get bundled up with the rest of your app and will get shipped down to the phone. And that's all good. But there's a catch with that, if you like. So on the phone, when the user installs an app onto a Windows Phone device, it gets pulled down from the store into this install folder, and it gets exploded there. A zap is just another word for a zip file. So it gets unzipped, and all the components end up in the install folder. When the app actually executes, it executes the code that the user has installed, and it executes, and it's volatile it's persistent storage, the flash storage that it's working with, its local folder is where it can create read and writable resources, such as files, settings, and databases. So the sample I've been using at the moment, you're creating it in the local folder, and those are read-writable. If you've got a reference database that comes down as content, it will be in the install folder, and it will be read-only. So you won't be able to write to that. If you want to then write to it or make updates, you're going to have to copy it from the install folder and stick it down into the local folder. The way you can do, there's another tip, and there's another pragma you need to be aware of here. So first of all, when you open it, this is another way of opening a database. You can use a application URI. Here we're using a application URI ms-appx SQLite read-only DB. So this is a database that's been shipped as content. It's ended up in the install folder, and that's the URI that will find it. And then you can, on the open async, you can put a open mode flag to say I want to open this in read. Now, if you're not doing any complicated joins or anything like that against the data, this next bit is probably not necessary. But the thing is, whenever you do complicated joins or complicated stuff against the database, complicated queries, it creates temporary storage, and it stores them in files. By default, it creates them in files in the same folder where the database is. Now, there's quite a nasty little gotcha here, in that actually, when you're using the Windows Phone 8 tools, development tools, and you work with stuff that's in the install folder, there's kind of a bug in that it will actually allow you to create new readable, writable resources. It will create files in the install folder. It shouldn't do, but it does. It's an error, and no doubt will get fixed in the next release. And this, of course, applies to hidden files you didn't even know you were creating, like temporary files that get created by the SQLite database engine. And it will work at dev time on a real phone and on the emulator. It will work. But then when you ship it up to the store and you've tested it and you go and find the errors and you send it out there, you get failures from people who are installing it onto regular locked phones. So the way to avoid that is to make sure that any temporary files are created in memory, not as disk files. And the way you do that is use that pragma, temp store equals 2. That makes sure they're created in memory. Obviously, make sure that if you do it, that you're not using too much memory as well. So if you're doing really big queries and complicated joins and stuff, that becomes another concern. In which case, you're probably better off shipping the database off into your local folder and doing it there, because you can use disk-based temporary storage files then. Oh, it does work, by the way, with databases on an SD card as well. That's another story. You've got to put a file association into your manifest, and you can open a database for read-only access again on a storage card. Storage cards are the same in Windows Phone 8. You can read stuff off them, but unfortunately we can't write to them. So that's another way of getting read-only databases onto a Windows Phone device. Right, I'm going to wrap up now. Just a little bit of talk about data synchronization. So I've got some good friends here, and we've been building these big systems for years with mobile devices, and we've been replicating data and all this sort of thing. And you've got a back-end SQL server, and you've got a client, and you want to copy some data from back-end SQL server, and you want to track changes, and you want to merge it back, and it's a complicated problem to solve. But actually, over the years, Microsoft has had some good solutions for this. But we've a little bit dropped the ball on this, to be quite honest, but with phone. So if you think about that complicated scenario where we've got a big database maybe in Azure, and you've got multiple clients out there, and say this is an enterprise line of business app, and you've got loads of delivery trucks, and they've all got Windows, well, maybe Windows 8 slates, or maybe they've got Windows Phone devices, where they've got ruggedized Windows Phone 8 devices that are coming soon. And they're all working off the same data, and they're doing deliveries and this sort of thing, and they're updating data. And the objective here is you're using a client-side database both for quick lookups, but also to store transient data and track changes. And then at some point later, you're going to sync the changes back from the client back to the back-end database. And doing this with multiple clients all working on the same data is a tough, tough problem, because you've got to worry about clashes between different clients updating the same records, the conflicts and this and that. How do you handle all this sort of thing? And the server needs to keep track of all of the clients and what sync level they're up to and be able to sync changes. Now, we used to have SQL Server merge replication is designed for this job. We cannot use that with Windows Phone, unfortunately. We used to use it on Windows Mobile, but it's not available for Windows Phone. It's not available for Windows 8. So we have to sort of think a bit about, there's kind of solutions out there. There's the Sync Framework Toolkit, which was released a couple of years ago, which kind of tries to solve this problem. But to be honest, it's a lot of work, and you need to put a lot of effort in. But there always was, as well, another simple synchronization solution, which actually does meet a lot, not all, but meets a lot of needs. And this was called Remote Data Access. How many people remember RDA? So Ginny does there, and a couple of us, yeah. So RDA, we used to use RDA. So it's great, it's simple, it's brain dead simple actually, but for I've seen a lot of situations where merge rep has been put in where actually RDA would have been just as good. Merge rep's great, but it does need a really on-the-ball DBA to be looking after the server side, and so it's not a dead easy solution to put in. But RDA is easy because all you do is every time you want to sync the client, you just drop the table and pull the whole lot down from the server. So you pull a new copy down to the client, and then you can turn on change tracking, and the client can then work offline. It can be working on this data, and it's tracking its changes, and then at some point later on in your code, you'll sync those changes back up to the server. They get applied to the server, and everything's in sync. There's no conflict detection there, so it's kind of last updater wins. So you've got to ask yourself whether it's the right solution for you. But we can do this, RDA. Well, we can do a version of it because we've got triggers in SQLite, and triggers are great because triggers allow you to execute some SQL whenever an update's being applied to a record. So for a change tracking solution, all you need, a simple change tracking solution, all you need, first of all, you need some table with a single row in it, which has just got a change ID in it. So, and this just increments every time a change is made. It's just a case of, it's just like a flag, if you like. So that's my change ID table there. We're initializing it with a value of 0. And then on the tables that you want to track changes, you just need to add a column to it, which you can do on the fly like this, alter table, customer add column, change ID, integer, which is just going to be, again, used as a flag to flag any records that have been inserted or updated. And then we also need to keep track of any records that get deleted. And so we need another table called table name tombstone, which is going to just store the primary key of any records that get deleted. So that's the kind of infrastructure side. And then all you need is these 3 triggers. So you can have there are triggers you can put before delete or after delete, and before insert or after insert, or before update and after update. And in this case, we're doing after in each case. So after a delete on a customer, we simply insert into the customer tombstone table a new record, which has got the value of the deleted customer record in it, using this old.id in it. And then on an insertion, we increment the value we've got in our single row change ID table. So we just up the change ID, and then we insert the customer and update its change ID column. So we're putting that change ID value into it. And then similarly on an update, after an update, we increment the change ID and then put that into the customer, the change ID column. And then if you want to know what's changed, it's 2 simple select statements. Select name, change, well, whatever, I'm just selecting the name and the change ID, but whatever columns you want from customer, where the change ID is not null. And if you want to find out what's been deleted, you just select all the rows from customer tombstone. So I've got an example. Now, I don't want to oversell this because this is a work in progress. It's not like a toolkit or I'm not making a product announcement or anything here. I'm going to be posting this up. I may well turn it into a NuGet package. perhaps if there's interest. So if there's interest, let me know. But I do intend to put this out there as a solution, a nice way of doing RDA. So let's open the RDA one. Now, this is a simpler version of the same thing. Now, before I do that, I'm going to go off to SQL Azure. I've got my database in SQL Azure. So I can go off to SQL Azure. We can log in to SQL Azure. Put my password in. Oh, well, there we go. It's the standard PA. It is a test thing, and I shall delete it later or something. There we go. Right, and log on. So this is my SQL database up in Azure. And yeah, we can do select star from customer. So this is the master database that's in the cloud at the moment. It's very simple. I've just got 4 records in it. So this is the cloud database. Now back over on the client side of things, I'll start this guy running. This solution consists of a simple OData service, a web API service, and it's basically got a get everything method and a apply changes. I'll step through that in a moment. It says, don't worry about this web page cannot found. That's because it's been changed to use the host name. That's another topic. If you want to see my networking session I did on TechEd on Tuesday, that explains what that's all about. But this is empty at the moment. I haven't got any customers. The app.xaml.cs has got, here we go, it's just got a very simple database where I've just got a simple table. That's all that's in it at the moment. And of course, there's no records in it. So this button here says refresh. This is going to go off to my service. I've got my pull data. Pull, hey, how about that? RDA had 2 methods, pull and push. And this is pull data async, so we're referencing the originator of this. I'll step into this, and what this does is this is the gatekeeper thing. Configure change tracking. What does that do? So this is where we just apply our changes. So we alter the table, add column. We've got to try catch on that because that column might already exist if we've done this before. We're creating our change tracking table. We're initializing that to 0. We're creating a tombstone table. We're executing that. So that's a bit of plumbing. And then we begin a transaction. We delete everything out of the customer table. Well, actually, there's nothing in it. And we delete from the tombstone table. Then we enable change tracking. And what this is doing, well, first of all, there's 2 flavors of this, true or false. So we make sure there's no triggers on the table at the moment while we're just sticking everything into it. That's the idea. And then we go to data service, pull data async. This is going to make the call to the service. I'm just going to let that run at this point. And this is now, we're over in the controller. This is now over in the API, the web API service. So it's got an entity framework thing in it, and it just goes and pulls all of those customer records out of the database, returns them as JSON to we're back in the phone project now, and we're going to insert all those customers that we've got back into the local table. There we go. And actually, what I didn't show you there as well, we've now actually enabled change tracker. We've turned on all those triggers. So now I can go in and start changing a few things. Let's change her name to Elizabeth Brown. Save that. And we can add another one. Contoso Enterprises, that well-known thing. And they're in, I don't know, London. And put me on it. I'm going to save that, and we could delete Comercio Miniero. Delete that. And then at some point later on, and this is all happening offline at the moment, we can send those changes back, push data async. So now we go into here, and is the gatekeeper. We set a new change set object. There's our select statements to pull out the changed customers. There we go. And there'll be a number of them. We can add the first one and add the second one. And there we go. And then we get the tombstone ones. And then we're going to let that run, and that will send all that stuff. Now we're into the service again, and this is the logic that applies the changes to the database using the entity framework. That's it. Very simple. Really, really simple. And then we refresh our we're back on, I don't know why it's calling that a number of times. There we go. And we get the enigmatic message bot there to say that something's been created. And over back on SQL Azure, we can run our query again. And there we go. So Elizabeth Brown's been changed, and I'm in there, and that other one has been deleted. So a simple RDA implementation, very simple web API, and really not a lot of stuff on the client side, but I hopefully will turn that into a out-of-the-box solution for people who are interested. All right, you've all got cards. I'm just going to talk through all the stuff that you might have missed and this sort of thing, but you've all got cards you were given, I believe, as you came in. If you'd like to fill them in, then we can hand them to the end of the rows, and then I usually have an assistant at this point. Well, yeah, there we go, thank you. And they'll be collected, and I'll take a draw, and somebody will win a phone. So while that's all happening, I'll just talk through this stuff. We had a bunch of sessions. We've only got one left today, which is creating Windows Phone 8 apps for SharePoint, but I hope you'll catch a lot of the other ones on the video on Channel 9. And a whole bunch of hands-on labs. Still time to do some of those. Come down to the Windows Phone booth where we've got a device bar and an expert area, and this theatre presentations, and a bunch of us will be there the rest of today, so you can come and talk to us, please do. And of course, there's also not only a chance to win phones in this room, but there's also theatre sessions, there's phones being given away. There's a draw on the hour every hour if you go to one of the theatre presentations in the hall. And general resources, windowsphone.com.business. Now, please, there's some other resources there, of course, on Channel 9, Learning Technique and MSDN. Please give us a feedback. It's the first time I've given this particular talk, so I'd love to get your feedback about if it met your needs or the stuff you want to hear about. Apparently, you can scan this QR code to evaluate the session and automatically entered to win a prize. So there are prizes for entering evals. Thank you all very much, and I hope that was all very useful to you. So thanks very much for coming.